Hi and welcome back. This is going to be the second recitation problem from Recitation 1, and it's the same exact thing as the last problem, just different numbers. So now what we're doing is we're taking a complex number, this is our complex number, 4 minus 2j, and this is in rectangular form, and we just have to take this and convert it into polar form. So if you want to pause the video and try it yourself, now's a great time. And now I'm just going to assume that you've unpaused the video, and I'm going to go through with solving it. So the first thing, I probably should have mentioned this in the last video, but I'll mention it now. This is one number, right? When I say that this is a complex number, even though I've got 4 minus 2j, it kind of looks, not like I guess maybe a typical number. This is a complex number. It has a real part. That's my real part. This is my imaginary part up there. So pretty much that's, I guess, the first thing to get out of the way. And just like in the last video, our goal when we want to take this in rectangular form and convert it into polar form, we want to write this exactly like we did in the last problem as some form m(e) to the j theta. So anyway, I guess if you want a bit more in depth than that, maybe you should rewatch the first video. I went into much more depth in that video. I think this video I'm just going to pretty much do this problem. So if I just go ahead and draw my real and imaginary axes, this will be my real axis, this will be my imaginary axis. And let me just go ahead and plot this complex number on the real imaginary axis. So I have 1, 2, 3, 4 real units, 4 units over in the real direction, so that's at 4. And now I have minus 2 units in the imaginary, so I go down 1, 2. So my complex number falls right there on the real imaginary axes. So now I have got, if I draw a line from the origin to that point, that's my line. The length of that line is going to be my magnitude. And again, just like we had in the last part of the problem, I measure the phase angle from my real axis, from my positive real axis. That is where my phase angle is that I measure from. So I could measure this phase angle that I have right here. I could measure this phase angle that I have right here. I could even go around a couple of times. Could even spiral all the way around and measure that phase angle. It doesn't matter. I'm equally representing the same exact number, whether I go down first, just down a little bit, whether I go all the way around, whether I go all the way around a whole bunch of times. It doesn't matter. If I throw that, if I put that angle, so long as the angle is right, even if I have to go around a couple of times, that is this number. I will be representing the number correctly. You could say that, it's better form if you write it, as being, from the minus direction, or it's definitely better form if you don't go around a whole number of times. But that is still, you could say, an equally valid way of writing the number, because it's still going to be equal to this number when it's in rectangular form. So anyway, now that I've drawn on that graph a whole bunch, let me, actually, you know what, I'm just going to undo that. There. So now I've undone that, and actually, you know what, I'm not going, well here, I'm going to go in this negative direction first. So now I'm going to say that my magnitude, first off, my magnitude is going to be the exact same thing it was in the last problem. My magnitude is just going to be equal to my real part, which is 4. 4 squared, plus my imaginary part, which is 2, and I square that. And then I take the square root of that. So just like in the last problem, 4 squared is 16, 2 squared is 4, so I get the square root of 20, and then I can simplify that into 2 root 5. So now, that's my magnitude. My magnitude is 2 root 5, just like in the last problem. And now, to get my phase angle, again, I just take the arctangent, the inverse tangent or the arctangent. I said inverse tangent last time, so I'll use arctangent here just to show that it's exactly the same thing, of the imaginary part over the real part. And one thing I can say here, doing the arctangent, it doesn't always give you the, it can be kind of tricky. You have to sort of know what you're doing, I guess, a little bit when you maybe go into the second and third and fourth quadrants. For this one, it's going to work out if I just put in the fact that I have a negative imaginary part and a negative imaginary part and a positive real part. I'm going to get the correct answer out of this. So if I have minus 2, that's my imaginary part, divided by 4, right? My negative 2 is my opposite side. My 4 is my adjacent side, so I'm taking the arctangent of my opposite over adjacent. That'll give me my angle. And this is going to give us, this is actually pretty much the same exact thing we had in the last problem. So let me get the calculator out, clear that. And now this is going to go down to minus 0.5. So if I have 0.5 minus, and I take the inverse tangent of that, I get negative 0.4636. So my phase angle is minus 0.4636. And so now I can really just write my final answer, that 4 minus 2j, if this is my rectangular form, my polar form can be represented as 2 root 5 times e to the minus j 0.4636. I just took the minus sign and brought it out in front of the j. One other thing I guess I want to show you, so I've written, this is one way of writing the polar form. That is completely correct. If you wrote it on an exam, you would have gotten this answer right. Another way you can do this is, instead of going down like this, I could have gone all the way around. So now, if I want to go all the way around, pretty much what I would do is I would say that I want to have, I want to add 2 pi to that number, right? And I would pretty much, I should be able to get the same thing. So if I take, let me go ahead and get a calculator. So if I took this number and I add to that, I'm going to use my parentheses, 2 times pi, close paren, equal. So I can also write this, and this would be exactly equivalent way of writing this. I could write 5.8195. So I could also say that my phase angle is equal to 5.8195. Is that what it was? 8195. Yeah. So that's also valid, right? That is taking this number, adding 2 pi to it. It's as if we started at that point and just went completely around the graph. So that is equal to 2 root 5 e to the j 5.8195. And that is also an equally valid way of writing this number in polar form. So anyway, hopefully you found this useful, and I guess I'm just going to keep doing these recitation problems. Thanks for watching. See you later.